Hello students, welcome back to another algebra video, and welcome to the last video of chapter 2. That's right, we have already reached the end, I can't believe it. Okay, so same as usual, pause the video, try these problems in your notes, and then unpause it to try them, or to do them with me. Okay, so we are solving the inequality. Hey, it didn't say to graph, so I'm not gonna graph, cool, okay. So, to solve the first one, I need to get rid of this 1 over here. So I'm going to add 1 to both sides, doing the opposite of subtracting 1. And then we have 4b is less than 7 plus 1 is 8. And now to get rid of the 4, I'm going to divide by 4 on both sides. And I get b is less than 2. Wonderful. Wonderful. Okay. Next problem. I have an x over here and an x over here. So I know that I'm going to need to get my x's over here and my numbers over here. Okay. Oops, erased too much. Okay. So to get the x's all on one side, I'm going to combine, put my apples together. So, I'll subtract 3x from both sides, and I get 2x minus 12 is less than or equal to negative 4. And now remember, I want just x's over here, so I need to get rid of that 12. We'll do that by adding 12 to both sides to get 2x is less than or equal to negative 4 plus 12 is 8. And now divide by 2 on both sides. And we are running out of space, but x is less than or equal to 4. And you notice I didn't have to flip because I'm not multiplying or dividing by anything negative. Okay, and last problem. Parentheses first. Always parentheses first. So I have 2k. 2 times negative 5 is negative 10. Less than 2k plus 5. Alright, again I have k's on this side and k's on that, so I'm gonna have to move them. In order to move this 2k, I need to subtract it from both sides. That'll go away. And, it also goes away over here. 2k minus 2k, 0. Okay, so that leaves me with negative 10 less than 5. Is that true? Yes. Negative 10 is always less than 5. So, we have infinitely many solutions. Infinitely many solutions. Wonderful. Okay, so that's a quick review of what we did in the last video. Now, let's see what we're doing today. Solving compound inequalities. So, our learning target is that you know what a compound inequality is. What is a compound inequality? We know what an inequality is, but compound. Alright, and the success criteria is that you can solve compound inequality. Okay, so we need to know what they are, need to be able to solve them. Okay. Well, here is our vocab for what a compound inequality is. So, an inequality formed by joining two inequalities with the word and or the word or. So, here you can see you have something that looks like this: x greater than 2 and x less than 5. We might have y is less than or equal to negative 2 or y is greater than 1. You can also write The ones that say and, you can write this way. If they say or, you cannot write them this way. So the and ones, because it's like if I say peaches and mangoes, I can blend them together, right? But if I say mangoes or peaches, I do not want both, you know? So I can put them together when it says and, but if it says or, I can't combine them like this. So let's talk about that in a little more detail. When we say and, so again, this is the definition. Compound inequality is an inequality formed by joining two inequalities with and or. So when we say and, we are talking about the intersection of the graphs of inequalities. So here's a good demonstration of that. We have x is greater than or equal to 2, and that's this graph. Here we have x is less than 5, and that's this graph. But when you say and x is greater than 2 and x is less than 5, you can combine it. Clear. And you can combine it like this, which means, look at that, you take this chunk of the graph and this chunk of the graph, and now I am greater than 2, but I'm also less than 5, so I'm trapped right here in the middle, and I'm not taking the arrow that sticks out past here, I'm not using that. So, when you say and, you're taking the intersection. This chunk and this chunk are the same between these two inequalities. So I'm just taking this piece in the middle here. When you say or, see, when you say or, you have one arrow pointing this way and one arrow pointing that way. So you can put them on the same graph, but you're still going to have one arrow this way and one arrow that way. So or leads to 2 arrows, whereas and leads to a section or a chunk. So that's the difference between and or. So let's see an example. The first example is that we're going to write these. We are going to write them first, and then we're going to graph them. So you'll remember this from our very first video of Chapter 2, how to write an inequality. So let's look at part A first. We have a number x is greater than -8 and less than, okay, so x is less than or equal to 4. Okay, so we can write it this way, and that's fine, but we can also write it like this, how we saw with that and I like that. I like that a lot. And it makes it easier to graph too, kind of. So let's try writing it like that. That means we have, let's see, x. So I'm gonna put -8. I'm gonna put the smallest number all the way over here. So x is bigger than -8. So I just took this inequality, I picked it up, and I turned it around. That's okay? All right. And x is less than or equal to 4. So see how I combined those two like that? Okay. So now this makes it easier to graph, because now when I graph, I'm going to make my number line, and I'm going to put 0 in on there, just like we always do. I'm going to put 4 over here and -8 over here. Now, I'm going to put a circle on -8, because look at that, it's strictly greater than, so I'm not coloring it in. I'm also going to put a circle on 4, and I'm going to color that one in, because it is greater than or equal to x. Okay, and now I know that x is between those two, right? It's bigger than -8, but it's smaller than 4, so x has to be sandwiched in between those two. So I just Draw a line right in there. X, so when we graph and inequalities, the inequalities, or excuse me, the compound inequalities with the word and, remember that we're just going to end up with this section, or an interval, as we call it in math. When we graph with or, that's when we end up with a circle over here and a circle over here, like two arrows. But when we graph and, we're not going to end up with arrows. We're just going to end up with this chunk in the middle. So all the solutions to this inequality are in the middle right here. Okay. Let's move on to part B. A number y is at most 0. At most 0. So it needs to be smaller than 0, and it can also be equal to 0. But it cannot be more than 0. It can't be, because it's at most 0. Okay. Or y is at least 2. Let's see. At least means if I want at least 3 pieces of French toast, it means I could have equal to 3 pieces of French toast, or I could have more than. So at least 2 means 2 or more than 2. Okay, I had to think that one through to know. And again, you can just memorize what symbol goes with which phrase, but you can also just think through it. Wait a minute. At least 2. If I want at least 2 pieces of French toast, you know, and you can think through it that way. Okay, so now, when we have the word or, things get a little bit differently, because I cannot turn it into an inequality that looks like this. I just can't. It's not possible. Because x isn't going to be sandwiched in between 2 things. I have or. It's not 2 things together, it's 2 different. So, what I'm going to do is I'm going to make my number line. I'm going to have 0 and 2, and I want another number on there, so I'll put 1. Now, y is less than or equal to 0. So I'm going to put a circle that is all filled in here. And then because y is less than 0, it means that I want numbers that are less than or equal to 0. So, less than or equal to 0 means that I could have negative numbers. All negative numbers are less than 0. So maybe -2, -3, whatever you want, but the arrow is going to point this way. Okay. And we're not done yet because we still need to focus on this part. Y is greater than or equal to 2. So again, I'm going to have a closed circle on 2 because this is greater than or equal to. And if I want greater than 2, that means I'm looking at 4 or 10 or 20. So it's going to point that way. Make it nice and bold so that we can see. We're not talking about this section in the middle. We're talking about the 2 sections on either end. So I want to highlight, if we have and, we end up with something in the middle like this. And if we have or, we end up with 2 chunks off to the side. So that's the big difference between and, you're going to color in between, and or, you're going to end up with 2 separate intervals. Or not intervals. Regions. Okay, so let's check our solutions. Look at that. That's what we got, and we also got that same thing. And beautiful, our graph looked the same, and we had the same 2 inequalities. Wonderful. Okay, so now, example 2. We know how to graph them now. Cool, we graphed compound inequalities, but how do you solve them? How do you solve compound inequalities with and? Well, I will show you. So, you'll notice that now normally we just have something like this. And we can say, okay, Here's one side. I'm going to add 2 to both sides. But now, we're going to do the same thing, but you have to add 2 to every piece of this. So when I add 2 here, I have to add 2 over here and add 2 over here. So remember how we drew these lines to talk about different sides of the equation or different sides of the inequality? So now, when I add 2 to one side, I've got to add it to all the sides. This side, and this side. All need a 2. So, whoops, got rid of my lines there. Alright, so -4 plus 2 is -2. And then you keep your signs. There's the x, this 2 went away, and then you keep the sign, and 3 plus 2 is 5. And now, because x is the only thing in the middle, we have solved the equation. So x is by itself, in the sense that x is the only thing in this portion of the inequality. So it is all by itself in here, and that's what we want. Okay, if you got that, you're like, booyah, awesome, I'm ready, try part B by yourself. If you're like, no, don't leave me, that's okay. You can do it with me. All right, so again, I'm going to draw these lines because it helps me know where I have to add or subtract to. So the first thing I'm going to do, I'm going to get that 1 out of there. And remember, if I do it to one side, I got to do it to all the sides. And now -3 minus 1 is -4. Leave the sign there, and I have -2x. Leave the sign here, and I have 9 minus 1 is 8. Okay. Now, I look in here, and I see that I have -2 times x. I'm going to do the opposite of times, and I'm going to divide by -2 on all the sides. Get rid of that there. -4 divided by -2 is, positive. Ooh, not negative. It's +8. No, not 8. Oh my goodness. It's +2. And, oh, wait a minute. I divided by a negative number. That means I have to flip. I gotta flip it. I gotta flip all my inequality signs, because I'm dividing by a negative number. So now all the signs do the same flippy dance. Okay. I'm left with just x in the middle because that -2 is out of there. And 8 divided by -2 is -4. Okay. Wonderful. And look at that. X is all by itself in the middle there. So we are finished. Booyah. Okay, let's check and make sure that we were right. Aha, -2 with x in the middle, and +2, -4 with x in the middle. Wonderful. I totally missed. We needed to graph it. Look at that. Everybody makes mistakes, even the teacher. So let's go back and graph these. We'll do this one first just because we just finished it. So we need 2, always 0, and then -4. So the sign that goes with the -4 is greater than or equal to. So that means I'm going to have my closed colored in dot. And the sign that goes with the 2 is strictly greater than. So we're going to have an open dot. And remember, x is right there in the middle, so we're just going to color in the middle. And that's where our solutions are right there in the middle. Ta-da! Okay. Let's go back to part A and draw our graphs. We have -2, 0, and 5. The sign with the 5 is open, and the sign with the -2 is also open. And of course the x is in between them, so I'm just going to color between our 2 circles. So that is when you solve compound inequalities with and. you will graph between your two circles. Whether they're open and closed or open and closed, doesn't matter. All right, and there we go. Our graphs look the same, and now we can move on. Happy. All right, now we're going to look at compound inequalities with OR. So now we have with OR, highlighted again, and so now this is a little bit different because I can't combine them. So up here we talked about doing it to all sides, like adding 2 to every side. But here we won't be able to do that. Instead, what we're going to do is we have 3y minus 5 is less than negative 8, or 2y minus 1 is greater than 5, with a big old or in the middle. So what we're going to do here is we're going to solve each of these separately. This one or that one. We're going to solve them separately and then just put them on the same graph. So I'm going to look at this one first. I have 3y minus 5, so I'm going to add 5 to both sides. And now 3y is less than negative 8 plus 5 is negative 3. And then 3 times y means I'm going to divide by 3. So that is y less than, and remember, I'm not flipping the sign because this 3 is not negative. It's a positive 3 I'm dividing by, so I'm not flipping my sign. And negative 3 divided by 3 is negative 1. So this is part of it. Y is less than negative 1 is part of it, but we still have this or. So now let's go figure out, we have or y something. So this inequality we'll look at now. I'm going to add 1 to both sides. And I get 2y is greater than 5 plus 1 is 6. And now, of course, I'll divide by 2 to get rid of the 2 on that side. And 6 divided by 2 is 3. And again, I don't have to flip because I'm dividing by positive 2, not negative 2. I only flip when I multiply or divide by a negative number. Okay, beautiful. So now we have each of these pieces that will go on our graph. So we have negative 1, we have 0, and we have 3. So now I have negative 1, and that's going to be an open circle because that is strictly greater than, excuse me, strictly less than. And if y is less than negative 1, it means I'm going to have all the numbers that are smaller than negative 1. So like negative 5 or something like that. All right, and if y is bigger than 3, it's greater than 3, that means I want numbers like 6 or 8 or 9, all the numbers bigger than 3. So I'm going to keep the open circle because that is strictly greater than, and my arrow will go this way. Denote all the numbers bigger than 3. Awesome. So remember that when you have or, you're going to end up with some sort of situation where they're pointing away from each other. And when you have and, it's and that gives you the chunk in the middle. All right. Let's see if we were correct. Yup. You solve them separately just like this. That's just what we did. Y is less than negative 1 or greater than 3. And that's exactly what our graph looked like. Boom. Okay, that's all I have for you in this video. I know it can feel like a lot, but I recommend rewatching the video if you need that. If you're still like, wait a minute, so much happened, that's okay. Give it a couple minutes, maybe rewatch parts of the video that confused you, but get your questions answered, whether that be with a friend, with your teacher, commenting on this YouTube video, something like that. Get those questions answered. Okay, some practice problems. You know how it is. These might not be the problems that your teacher assigns for homework, so don't think that this is homework, but these are problems that you can do to test and make sure that you understand what was taught in this video. And now, let's end on a launch. End with our launch. So, happiness is not by chance, but by choice. So what that means is you don't just happen upon happiness. It's not just like, wow, I'm so happy. Where did that come from? Like, no. It's by choice. You have to choose to be happy. This is like the launch we talked about last time. You have to choose, like, I'm gonna make my life beautiful. I'm gonna make my life what I want it to be. And the same is true with happiness. I went through a lot of like counseling and therapy, which is good. It's good for my brain. I learned how to take situations that normally would make me really sad and go, you know what? This is okay. Like when a boyfriend of mine dumped me or something, I'd be like, wow, this sucks. And that doesn't mean that you can't be sad. Like, of course, if your boyfriend dumps you, you want to be sad. But also, you don't just sit in that sadness like, no one will ever love me again. I am doomed. Like, no. You know, he didn't see the value in me. He didn't want me, but somebody else is gonna want me and is gonna love me better than he ever could or wanted to. And I want to be with somebody that wants to love me and wants to be with me. So eventually, like, of course, be sad for a little bit, but then you can change your mindset of like, you know what? It's a good thing. It's a good thing. Like, I really miss him, but I will find somebody else. And that I can be happy about. So you can always find something to be happy about. And this, I want to make it very clear that you don't get to just say, happiness is a choice, so get over whatever is making you sad. Like, depression is a very real thing, okay? I know it's a very real thing. So I'm not trying to say cover up your depression with a happiness sticker and just say, oh, be happy, choose to be happy. If you truly think that like you have or feel that you have depression and you cannot be happy, it is okay to talk to somebody and get help about that. You should not feel any shame in getting medication if that's what you want to do, or talking to a counselor. There's nothing wrong with that. That's healthy and that's a good thing to do for your brain. We all deserve to be happy. So, in certain situations, you can choose to be happy. In other situations, you might want to talk to your doctor or talk to a counselor, and that's okay too. But either way, talking to a doctor or a counselor is a step to choosing your happiness and your mental health. So, focus on happiness, don't focus on the crappiness. Yeah, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thank you for being here. Thank you for watching. Bye.